Welcome to the Python crash course. In this course, I'll teach you key features of Python that are utilized in the real-world projects most often. And we will cover following topics: base types, like strings or integers; container types, like lists or dictionaries; variables assignment, conversions of different types; comparison and logical operators, if-else conditional statements, functions, loops, and strings formatting. Let's dive in, and first you need to verify whether Python is installed on your computer or not. For that, please open up any terminal application. On Mac I'm using iTerm 2, also it's possible to use default terminal application. If you're a Windows user, you could use PowerShell or Git Bash, for instance. Here in the terminal, please type Python --version. If you are on Mac, please type Python 3 --version, because there are two different versions of Python available. And in this crash course, we will utilize third version of the Python, this latest one. On Windows or Linux systems, simply type Python --version. Let's check that, and I see that on my computer there is Python 3.9.4 installed and available for use. If you see error command not found, you need to install Python. In order to install Python, please go to python.org/downloads and download Python for your operating system. It is available for Windows, Linux, macOS and others. And after that, please recheck version of the Python. If you see specific version here in this output, you are good to go. Alright, let's get started with Python, and in the first part of this course we will use Python interactive shell. In order to enter such shell, you need simply type Python on Windows or Linux and Python 3 on Mac. And after that, press Enter. Interactive shell was launched, and here I see details about specific Python installation. In my case, I'm using Python 3.9.4, and here is exact version. And also below you see interactive command prompt that consists of 3 greater than signs. And basically here you could enter any Python commands, and Python interpreter will interpret them and produce some result. For instance, let's call print function that will print a result of specific expression to the terminal. And here, in those parentheses where we actually call this print function, we could enter, let's say, string hello from Python, and press Enter. And I see hello from Python here in this interactive shell. You could also print multiple expressions, for example, string ABC and number 10, like that. And I get ABC and 10 here in the terminal. Now let's talk about base types in Python. And there are such types as integer, number without decimal part; float, number with decimal part, for example 2.5; string, ABC, you could use either double quotes or single quotes, both work; boolean, either true or false; none, that is used in order to represent value that is undefined. You could also verify type of any value using type function. Type, parentheses, and here let's check type of the number 2. And I see class int. Why class? Because Python is object-oriented programming language, and any value is basically instance of specific class. And here we see that this number 2 is instance of the class int, integer. Let's check type of the float number, 1.5. I see class float. Let's check type of the string, ABC, class str. Let's check type of the false or true value, I see bool. And let's check type of the none. I get class none type. You could very easily convert value of one type to another using such functions as str, that stands for string, int, integer, float, and bool. I could convert to string, for example, number 100, and here is string. Also, I could convert to string boolean value, for example, true, and I get string true. Let's convert to integer string 50, and I get number 50. Let's convert to integer boolean value true, and I get 1. If I convert false, Of course, I'll get 0. Let's try to convert to integer string, for example, ABC. And Python was not able, of course, to convert such string to integer. And I got value error invalid literal for int function. In Python, same as in many programming languages, there are falsy values. Falsy values are values of different types that are evaluated to false when converted to Boolean. And in Python you could convert any value to Boolean using bool function. And there are following falsy values. Integer 0. Here we get false when it is converted to Boolean. Float 0.0. Empty string. Boolean false. Of course we get false here. None. Also falsy are empty values of container types. For example, empty list or empty dictionary. We will talk about container types a bit later in this crash course. In Python you could declare new variables and assign values to them, and it's a convention to name variables using lowercase letters and underscores between them. For example, my underscore name. Or, for example, my favorite song, like that. If you want to create constant variable which value will not be changed through the life cycle of the Python application, you should use uppercase letters. For example, my underscore API underscore key. But please notice that Python does not distinguish between constant and non-constant variables. There is no difference for Python whether you name variable myAPI uppercase or myAPI lowercase. In both cases, you will be able to reassign value of the variable later on somewhere in the code. But if you name variable like that, it will be sign for you that you should not assign new value to such variable. Declaration of the variable and assignment of the value to it is as simple as that. My underscore name equals sign Bogdan. Now I am able to access value of such variable anytime and I get string Bogdan. Also I could check type of my name variable and I get class str string. Python is dynamically typed language, and that means that you are able to change type of the value that is assigned to the variable. For instance, here I could type my underscore name equals sign true. And now if I access my underscore name, I get true. And now type of the variable is bool. And that's the reason why you should use meaningful names in order to avoid such occasional reassignment of the value. If variable name is my name, then of course you should expect string value for such variable. Let me change value of this variable back to Bogdan, like that. If you want, for example, use Boolean value for the variable, you should name variable accordingly. For instance, good name will be is logged in with value true or false in order to track whether user is logged in or not. Also, you could copy variables. For example, other name could be copy of my name. And now if I access other name, I get Bogdan, and if I access my name, I get Bogdan as well. If I reassign value of the variable other name to, let's say, Mike, and access other name, I'll get value Mike, but if I access my name variable, it still holds value Bogdan. And that means that with base types, when you copy one variable to another and change value of that another variable, value of original variable, like my name, does not change. And that's due to the fact that variables that hold values of base types are copied by value. Actual value is copied from one variable to another. And that's why when we modified value of the other name variable on this line, value of my name variable was not changed. Now let's define new variable and let's call it age, and its value will be integer 21. And now let's assume that you want to increment value of this age variable by 1. You could do that in following way: age equals sign age plus 1. We actually use current value of age variable and increment it by 1, and afterwards new value is assigned to the same variable. If I do that, now value of the variable age is 22. Also, you could perform same operation using plus equal operator, and let's assume that now we want to increment the value of the variable age by 2. Age plus equal 2. No need for two different operators here and here, you could use just single operator plus equal, and now value of the variable age is 24. Similarly, you could decrement value of the variable by using minus equal operator. Age minus equal 5, let's say, and now age is 19. Also, you could assign none as value of any variable, and also you could delete a specific variable using del operator, like that, and now there is no such variable. We already discussed base types like string or integer, and now it's time to talk about container types in Python. And there are such container types as list, tuple, dictionary, and set. Dictionary and set are unordered sequences of some values. List and tuple are ordered. And let's start with list. You could create list using square brackets notation. And here is empty list. You could assign empty list to any variable, for example a. Now type of the a is list, and now it is empty. You could check length of the list using len function, like that. And now length of the a is 0, it has 0 elements. Now a as instance of the list has many different methods that you could call using dot notation. If you type a and dot and press tab twice, you'll see which methods are available for use. There are such methods as append, copy, count, clear, and so on. You could use append in order to add new elements to existing list. Let's do that. A.append. And let's append number 2. If I access a now, there is one element inside, and now length of this list is 1. Let's append one more element to this list, and let's append string abc, for instance. And let's check now. And now a contains two different elements, and now length of the a is of course 2. You could access specific element of the list using its index, and indexes start with 0. Index of the first element is 0, and index of the second element is 1. And you could use square brackets notation for that, a square brackets 0. And I get 2, it is first element in this list, and it has index 0. Let's access second element, and now instead of 0 here will be 1, I get abc. But if I try to access element that doesn't exist, for example, let's put here index 10, I'll get index error, list index out of range. Let's add one more element to this list, a.append. By the way, you could always use tab in order to autocomplete, for example, name of the method you want to use. And here let's add element true, it is boolean value. Now length of the a is 3, and let's say that you want to access last element in this list. For that, you could use such syntax as a square brackets -1. Negative indexes like -1, -2, and so on allow you to access elements starting from the end of the list. Now a has 3 different elements, and if you want to remove last element in the list, you could use pop method a.pop, like that without any arguments. It returns element that was just removed, and now a has just 2 elements. Also, it's possible to remove all elements from the list using clear method, and now a is empty. Alright, let's remove this variable a. Lists are mutable in Python, and that's the reason why we were able to modify value of the variable a in the previous examples. There is also immutable container type called tuple. Let's create new variable b, and its value will be in parentheses. And here let's type, for example, 2 and abc. Let's perform this assignment and let's access b. Now it has 2 elements, 2 and abc, and type of the b is tuple. If I now enter b dot and press tab twice, I'll get only 2 possible methods that you could use with tuples, count and index. There are no such methods as append or pop. And difference between tuple and list is that tuples are immutable. You are not able to add new elements to the tuple. For instance, if I even try to enter b.append and type here, for example, 10, I'll get error. Tuple object has no attribute append. But you are able to access elements in the tuple same as we did with lists, using square brackets notation, b square brackets 0, and I get 2 is first element in this tuple with index 0. Similarly, I could access second element with index 1, it is string abc. Also using index method, you could get index of specific element. For example, index of the string abc is 1. I would recommend to you using tuples anytime when you want to create ordered list with different values. But you don't want to modify those values or add new values in the future, even occasionally. That's where tuple is a perfect choice. Let's move on, and next let's discuss unordered container types, dictionaries and sets. And let's start with dictionary. Dictionaries are represented using pair of curly braces, and they contain key-value pairs. Key is string, for instance key 1, with value let's say true, and key 2 with value let's say number 10. Notice that order of the keys in the dictionary doesn't matter. You could first type key 1 and key 2 afterwards, or swap the order and first enter key 2 with its value and afterwards key 1 true. Alright, let's create new variable and let's call it person, and its value will be dictionary with single key, name, and its value will be string Bogdan, like that. If I access person now, I'll see dictionary with single key name and its value Bogdan. Type of the person is of course now dictionary, dict. You could access value of specific key in the dictionary using square brackets notation, person, square brackets, and here in double quotes type name of the key, name, and I get Bogdan in this example. But if you try to access key that does not exist in the dictionary, for instance age, I'll get key error age. And if you don't want to get such tracebacks in case you access non-existing keys, you could use get method of the dictionary, like that, person.get, and here let's get age. Now I don't see any error, and actually if specific key is absent in the dictionary, then get function will actually return none, but none is not printed by Python here in the terminal. We could actually ensure that it returned none by converting result of the person.get function call to string, like that, person.get, for instance age, and now I get string none. You could also assign default value in this function call in case such key is absent in the dictionary, using following syntax: person get age, and here after comma specify default value for this key, for instance 18, and now I get 18 as a result of this function call. That's why if you are not sure whether a specific key is present in the dictionary or not, I recommend to you using get method instead of square brackets notation. In such case, you'll get key error in case specific key is absent in the dictionary. Alright, now let's examine which methods except get are available for use in person dictionary. Let's type person, dot and press tab twice, and there are such methods as clear, keys or values. But unfortunately there is no such method as append. And now question, how you are able to add new keys to existing dictionary? Very easily, using square brackets notation. Person, and here in square brackets will be string with new key, let's say happy, and value of this key will be true, like that. Now if I access person, I'll see two different keys, name and happy. You are always able to modify value of specific key using same notation. I could modify value of the key happy to false, for instance, and now value here is false. Alright, let's get back to true. You are also able to get length of specific dictionary using len function. Let's call it len person. And now I get 2. Now this dictionary has two different keys. Using person keys and person values methods, you are able to get keys and values of specific dictionary. Let's first try person.keys. As a result, I get dictionary keys, and here you see structure that is very similar to list with two elements, name and happy. But this result is not a list, it is instance of the dict keys. And let's check that using type, and here will be person.keys, like that, and I see class dict keys. You could always convert dict keys to list if you want to do so using list function, list person.keys. And now I got list with two elements, name and happy. In similar way, you could get values of specific dictionary, person.values. And now I get dict values with two elements, Bogdan and true. Similarly, you could convert it to list using list, and here will be person.values, like that. And now there is list with two elements, Bogdan and true. Recap that with lists you are able to get specific element using square brackets notation. For instance, I could get first element with such syntax, square brackets, and here with 0, like that. I got Bogdan. Also, values in the dictionary could have container types, for instance, list or other dictionary. Let's add new key to the person dictionary using square brackets notation, and here will be hobbies, and its value will be list, square brackets notation, and here let's put books and snowboarding, like that. Now person hobbies key was added, let's check that, and now there are keys in this person dictionary, name, happy and hobbies. And now if you want, you could modify this list here, either add new elements or remove elements or modify elements using such syntax as person, square brackets, hobbies, and here let's use pop method and remove last element in this list. Let's do that. Snowboarding was removed and now there is just single element in this list here. Also, you could delete specific key from the dictionary using del operator, like that. Del, person, and here in square brackets will be name of the key, hobbies for instance. And hobbies key was just removed. Now person variable is dictionary. And what if I want to copy this dictionary to another variable, for example, another underscore person? Let's do that. Another person equal sign person. And now another person has same value as person. Now let's try to modify another person variable, and for instance, let's modify this name here. Another person, square brackets, name, and let's change name for instance to Bob, like that. Now name in another person variable was changed to Bob, but if I try to access person, I'll see that name was changed here to Bob as well. And the reason for that is that dictionary in Python is reference type. And now those variables another person and person hold actually pointers to the same place in memory, this place, where this dictionary is located. And when you modify, mutate, in other words, this dictionary, here we did that, you mutate it only in one place. And those pointers, another person and person, still point to the same place in memory. That's why here we see exactly the same dictionaries. That is called copy by reference. When you copy value of base type, for example string or boolean, you copy by value. Actual value is copied from one variable to another. With dictionaries, situation is opposite. We copy only pointer. That's very important to keep in mind. Same applies to lists. If you create list numbers, for instance, and its value will be list with numbers 1 and 2, and afterwards you copy numbers to another numbers, for instance, like that. And now let's add one more element to the numbers list using append method, and let's append number 3. I'll see that another numbers and numbers are the same. And the reason here is the same as for dictionaries. List is reference type in Python as well. And here on this line we copied only reference, not actual value. Value is the same for both variables, another numbers and numbers. Alright, that's what is called copy by reference, and please always be very careful when you copy values of such types as dictionary or list. Now let's have a look at one more container type in Python that is called set. Sets are created using curly braces, same as dictionaries. But they don't have keys and values as dictionaries do. Instead, set consists of elements, and each element must be immutable. It means that you are not able to insert to the set other dictionaries or lists. For instance, set could contain following elements: ABC, B, and 10. Now let's assign such value to the variable, for instance my_set, and now let's have a look at the type of the mySet. And I see that mySet is instance of the set class. Now let's have a look which methods are available here from mySet variable. Let's press two tabs here, and I see many methods like copy, difference, discard, isSubset, pop, remove, and so on. Sets have even more methods than dictionaries in Python. But how sets actually differ from dictionaries? Let me demonstrate to you. Let's try to add one more element to my set that now has only 3 elements: A, B, C, 10, and B. Notice that order of those elements here in this output differs from the order how I actually entered elements when I created this mySet variable. I entered A, B, C, B, and 10 first, but here in this output I see A, B, C, 10, and B. It means that order in sets does not matter, same as in dictionaries. But let's try to add one new element to this mySet. For that there is method add, and let's add new element true. Let's access mySet now. Now there are 4 elements. Let's add one more element, for instance number 20. Now there are 5 elements in the set. But if I try to add element that is already present in the set, for instance let's add number 10, I'll see that my set was not changed, and it still has only 5 elements. And that's what makes sets unique in Python. Set holds only unique values, and it doesn't add duplicates. And in some cases such feature of sets might be very useful. Sets don't store duplicates. You could of course remove specific element from the set using method remove, and let's remove element 20. And element 20 was successfully removed from the set. Now let's briefly summarize key features of different container types. First type is list, represented by square brackets, and here could be different elements, for instance integer, boolean, or string. This is list. Next there are tuples, represented by a pair of parentheses. And here could be same elements as in list: 1, true, or let's say string. Also there are dictionaries, represented by a pair of curly braces, and dictionary has key value pairs. For instance key 1 has value 1 and key 2 has value string ABC. Also there are sets, represented by same pair of curly braces, but sets only have values, for instance 1 and ABC. Difference between those 4 types is following. Lists and tuples are ordered, and any element in list and tuple has its own index. Index starts with 0. Index of this element is 0, index of this element is 1, and so on. Difference between lists and tuples is that lists are mutable. You could change any value here, add new elements, remove elements, and so on. Tuples, on other hand, are immutable, and you are not able to modify those values, and also you are not able to add or remove elements from the tuple. Dictionaries and sets are unordered in Python. Order of the keys here does not matter, same as order of those elements in the set. And you could access any element in the dictionary by its key name, for instance key 1 or key 2, and also you could add new keys if you want to do so. Using del operator, you could remove specific key from the dictionary. It means that dictionaries are mutable, same as sets. You are able to mutate set, add new elements, remove elements, and so on. And difference of the set from the list is that list might contain same values, but set might contain only unique values. And if you attempt to add element, for example ABC, to this set, nothing will change, and set will still contain only two elements, 1 and ABC. That's the difference between four different container types: lists, tuples, dictionaries, and sets. Now let's exit from the Python interactive shell by calling exit function, and the remaining part of the course we will spend in the Visual Studio Code, and there we will talk about functions, if-else statements, and other Python features. In the remaining part of the course, I'll use Visual Studio Code Editor because I'll create multi-line blocks of Python code and run it, and it's not a good idea to continue working in interactive shell, and that's why if you don't have VS Code installed on your computer, I highly recommend you install it as well, because we will use one of its extensions that will allow us to automatically execute Python code using keyboard shortcut or using Run Code button. So, if you don't have VS Code, please go ahead and install it from code.visualstudiocode.com. After installation, or if you already have VS Code installed, please open up any terminal application and let's create a folder for our project. I'll do that on the desktop, and I'll create a new directory here, and let's name it python-crash course. Let me cd to this newly created folder, and let me open it up with help of code and dot command. If in your case this command is not available, you could open up VS Code manually and go there to File Open and open this newly created folder there. So let me open it using this shortcut command. Here we are, project was opened in the Visual Studio Code. Let me make it full screen and let me close this welcome page. Now let's create a single file here in this Python crash course folder. For that, click on this icon and let's name file main.py. Let's now close this left pane like that, and let's write some Python code here in the main.py file. For instance, print hello from Python. Let's save changes, and now question how to execute this Python application directly here in the VS Code. We could do that manually by going to terminal and click new terminal. New terminal was opened, and notice that you are now in the Python crash course folder. That's why here please type Python and name of the file you want to run, main.py. You need to type such command if you are Windows or Linux user. If you are on Mac, please change Python to Python 3 like that. Let's press enter, and Python will interpret this file for you. And here is the result of the execution of this specific file, hello from Python. But it's not convenient to run such command anytime when we will make some changes in this file. That's why, for simplicity, let's install one of the VS Code extensions called Code Runner, and using Code Runner we will be able to run this code much more easier and faster using shortcut or this button here. Let's go to Extensions, and here in Extensions search for Code Runner. Select Code Runner and click Install. Code Runner was installed, and if you scroll a bit down here in the description, you'll find how to run it. Let me search for shortcut here, and here it is in the usages section. To run code, you could use shortcut Ctrl-Alt-N, or use this button here. Let's go to main.py file, and first let's click on this button and select Run Code. And here I see a result of running this file using Code Runner. I see such sections as running and done, and unfortunately I don't want to see them anytime when I run this program using Code Runner, and that's why in a moment I'll explain to you how to modify settings of Code Runner in order to avoid displaying of such messages. Also, we will clear our previous output anytime when we will run Code Runner again and again. Also notice here that on this line Python interpreter was used on my computer, and if you are a Mac user, I'll explain to you how to change it from Python to Python 3. Let's go to Settings, Code Preferences Settings, or use shortcut Command, comma or Control, comma, and let's search here for Code Runner. You'll find settings that contain Code Runner somewhere in the description or title, and let's filter further, and let's add here filter Save, like that, and you'll find two options: Save all files before run and Save file before run. I'll check this checkbox, and when you'll run any file using Code Runner, it will first automatically save the file and afterwards run the code. Now here let's search for clear, like that, and check this checkbox clear previous output. Now let's search for code runner message, and you'll find option show execution message like running and done. Let's uncheck this checkbox. And if you are a Mac user, please enter code runner exec, and you'll find option code runner executor map. And you need to open settings.json file and edit the setting for Python interpreter there. Please click on edit in settings.json and search for Python here. And change python-u to python3-u. And save changes in this settings.json file like that. Now we are all set. Let's try to rerun our main.py file here. Let's click here, run code. And now I see only hello from Python. And if I modify a file and add here, for instance, exclamation mark like that and save changes in the file, run it again, run code, I'll see that previous output was cleared. Also, you could use shortcut Ctrl-Alt-N in order to run code quicker. Let's modify file once again and press key combination Ctrl-Alt-N, and I see updated result here in the output. Hello from Python with 2 exclamation marks. Also, you could modify position of the terminal. Now by default it is under the file, and if you want to move it here to the right, you could right button click here and select move panel right, like that. And now terminal is open here on the right side of the file. It is more convenient for me. So now we are all set, the code runner is installed, and anytime when you want to run this code, you need to press key combination Ctrl-Alt-N like that. Alright, code runner extension is installed in VS Code and we are ready to proceed. Next topic is functions in Python. Function is defined using def keyword. Afterwards comes name of the function, for example, my_name. Next pair of parentheses, and here inside you could put parameters of the function. Let's for the moment keep this function without any parameters. Next there is colon. And on the next line, after tab, notice that VS Code has added tab automatically, you could add function body, and it consists of statements. Let's write here simply keyword pass, like that. And afterwards below, let's call this my_name function, like that. And let's run this code. Code was executed, but here in the output I see nothing. Let's try to print result of this function call like that. Print. And here inside will be called to the my_name function. Let's now save changes and rerun. And now here I see none. And that's a result that is returned by this my_name function. This keyword here actually does nothing. And you could use such keyword in the function body when it does not need to do anything. But you need to add at least one statement inside of the function. That's why pass is a very good option to create empty function like this one. Now this function is defined and we could call it multiple times. For instance, I could copy this line and call it once again, and now I'll see none 2 times. Now this function my_name has name, but doesn't have any parameters. And by default, function returns none if there is no return statement. Let's add such return statement instead of pass. And let's return, for example, number 10 like that. If I run now application, I'll see 2 times number 10. And that's how you could return specific value from the function using a return keyword. Now let's add parameters to this my_name function. Parameters are added here in the parentheses. And let's add parameter name. Now we are able to call my_name function with argument. And I could add here argument, for instance, Bogdan. And here in this next function call, I could add another argument, for example, Bob. And let's also return name instead of number 10. Let's now save changes and run application. And now here I see Bogdan and Bob in those 2 function calls. Notice that here is parameter and here are arguments. Here is argument and here is argument. Each time when you call a function, you pass different arguments to it. Also notice that if you don't pass argument, for instance here, you'll get type error, missing required positional argument name. And in such case, you are able to assign default value for specific parameter. And syntax is following: name equal sign, and here could be default name. For example, no name specified, like that. Let's now run application, and now here in this function call I see Bogdan as a result of this function, and in this function call I see no name specified. Because now here in this function call name parameter was assigned this default value, no name specified. That is default value for this parameter name. Actually, inside of this function, this name parameter is variable, and you could perform different actions with such variable. For instance, instead of returning name, we could return name.upper, like that. Let's save changes and run application, and now here I see Bogdan and no name specified in uppercase. Because here on this line we called upper method of the name. Name is string, and each string is instance of the string class, and string class has a bunch of methods including upper. That's why we are able to call it using dot notation like that. Also inside of the function body you could perform some actions. For instance, here let's print to the terminal message name value is, and here after comma let's add name. Let's now run application, and now here I see name value is Bogdan, that comes actually from this statement. Next I see Bogdan, that is a result of this function call that we print here on this line. Next I see name value is no name specified, that again comes from this print function call in this myName function call. And finally we receive no name specified, that is returned by myName function in this function call. It means that functions in Python could perform some actions like we do for example on this line and return some results like we do here on this line. Also notice that if you don't use return statement inside of the function body, then any function returns implicitly none. And that's what we saw at the beginning of this lesson. Now let's remove this function and let's define one more function. Let's use again def keyword, and the function name will be person_info. And here in the parameters section let's add two parameters, name and age. Next here is column, and on the next line will be function body. Notice that if you attempt to write block of the function without indentation, for instance return 2, let's save changes and run code, you'll see indentation error, expected an indented block. Because Python with indentation actually understands where function body starts. That's why you must add here indentation like that. And if I now run the file, I'll get no errors. Alright, let's now in this person_info function print to the terminal name and age. Print name, and on the next line let's print age. And here below let's call person_info function with two arguments, for instance Bob and age 25. Let's save changes and run application. Here in the output I get Bob and 25. It means that name parameter was assigned value Bob at the moment of this function call, and age parameter got value 25. And those arguments here in this function call are called positional arguments. If I change order here, and for instance if I pass first 25 and next type Bob, I'll get opposite result. 25 will be name and Bob will be age. And that's not what you expect from this function. It means that with positional arguments, order is important. It matters. That's why when you type person_info and add pair of parentheses, VS Code will actually show you which arguments are expected. So first argument that is expected is name, here you see that it is underlined. And if I type Bob and add comma, I'll see that now I need to add age in the second positional argument. But also in Python you are able to use keyword arguments. Like that. Name equals sign Bob, comma, age equals sign 25. Let's now run this code, and I see that function was executed, and here is expected result. Name is Bob and age is 25. And now I am able to change order of those keyword arguments. Like that. First will be age with 25 value, and next will be name with value Bob. Let's now run application, and result is the same. It means that with keyword arguments, where you explicitly specify name of the parameters, age and name, order does not matter. Also, if you want, you could mix positional arguments and keyword arguments, like that. First will be, let's say, Bob. Let me remove this keyword argument from here. Let's pass Bob as positional argument, it will be first, and next will be keyword argument. Let's now run code, and the result is the same, Bob and 25 here. It means that you are able to mix positional arguments and keyword arguments, or named arguments. Now let's create one more function, and let's name it sum, def sum, and here will be, let's say, two parameters, a and b. And I want to return sum of a and b, like that. And let's here call this function, and let's immediately print result of the function call to the terminal, and here will be sum with two arguments, 5 and 2. Let's now run application, and I get 7 here in the output. But what if I want to sum all arguments that are passed in the function call? For instance, 5, 2, 10, 15, and so on. If I try to run application now, I'll get type error. Sum takes 2 positional arguments, but 4 were given. And that's reasonable. Here we specified only 2 parameters, but we passed 4 arguments. And that will lead to such kind of error in Python. But how we could solve this problem? What if I want to call function with any number of arguments? And here inside of the function I want to sum all supplied arguments. For that, inside of the parameter section I could use following syntax: star and args. And here now let's print to the terminal args, like that. Let's see what we'll get here. And on this line I get tuple with values 5, 2, 10 and 15. It means that now we are able to call this sum function with any argument's quantity. It does not matter. With such syntax in the parameter section, this args variable will be defined inside of the function, and it will actually contain all arguments that were used in the function call. Let's print also type of the args, like that. Let's run, and I see class tuple. And now I am able to iterate over args variable and sum all values of those integers. Let's do that here. Let's first define new variable, total, and its initial value will be 0. Now let's iterate over arguments, and you could iterate using for syntax. For arg, in args, colon, and here let's do following: total plus equal arg. And finally, let's return total. In a moment I'll explain to you what happens here. Now let's just run this code. And I see result 32 here in the output. So what happens here? Here on this line we iterate over arguments. Every value of container type is iterable. We just saw here that args is tuple, and that's why we are able to iterate over elements of the tuple. Let's here inside of the for in loop first print to the terminal arg. Let's run the code, and I see 5, 2, 10, 15, and finally I see 32. That is the result of this function call here. And it means that inside of the for in loop there is variable called arg, and that's actually where this variable is defined. And we are able to perform some actions with such variable. In this example it is integer. And on this line we increment value of the variable total that was defined here by arg using plus equal operator. And after this for in loop, value of the total variable will contain sum of all arguments. And that's why here, when we return total, we get sum of all arguments passed in this function call. If I remove this line and add, for example, one more element here, let's add 10, run application again, I get 42. And it doesn't matter which quantity of arguments here you pass in this function call, all of them will be summed up here in this for in loop. Now let's talk about keyword arguments. Let's remove all of that from here, and let's define again function called person_info. And here recap, we use the two parameters name and age, and let's print to the terminal name and age, like that. Let's here call this function person_info with two arguments, Bob and 25, like we did before. Let's now run this application, and I get Bob and 25. But what if you want to have variable quantity of parameters here, not just two, like name and age? And let's say that you want to extend this function and you want to add other parameters, for instance, city, country, hobbies, and so on. But not in all function calls, all arguments must be present. And you want to have ability to call this function, let's say, only with two arguments, name and age. But in some cases you want to call it with more arguments, for instance, name, age, and city. How to accomplish such task? You could use keyword arguments, and syntax is following. 2 stars, args, like that. Let's here print to the terminal args. Let's save changes, run application, and now I get type error. Person_info takes 0 positional arguments, but 2 were given. This means that with such syntax in parameter section here, you are not allowed to use positional arguments like you see here on this line in this function call. You must use only named arguments or keyword arguments. Let's modify these arguments from positional arguments to keyword arguments. Here will be name, and here will be age, like that. Let's now run application, and now I get dictionary with 2 keys, name with value Bob and age with value 25. This means that with such syntax in place, arguments, keyword arguments, are automatically converted to dictionary. Let's basically ensure that it is dictionary. Let's print type of the args and run application. And yes, I see class dictionary. And now here inside of this function, you are able to work with args variable, same as you work with any dictionary. You could access keys, you could add new keys, you could modify values of the keys, and so on. For instance, you could print only args, square brackets, name, like that. And now you'll get value of the name key in this dictionary. It is Bob in this example. Also, let's add here city. For instance, Paris. And now I'm able to access city, like that. Let's run, and I get Paris. But what if city is not passed here as keyword argument? What I'll get? I'll get error, and error is key error city. And that's what we discussed before. If you attempt to access specific key in the dictionary using square brackets notation and such key is absent in the dictionary, you'll get key error. If key might be present and might be not, you need to use get method. Like that, args.get. And here will be city. If I run code now, I'll get none. Because that's that value that is returned by get method if specific key is absent in the dictionary. And now in this function call there is no keyword city, and that's why in this args dictionary there is no key city. And certainly if you want, you could assign default value to this absent key, for instance New York. And now I'll get New York here on this line. That's keyword argument feature that is represented using 2 stars and name of the variable. Of course, name here could be any you like, not necessarily args. For instance, we could change it to person, and let's modify it here, here, and here, and type person instead of args. Rerun code, and I see exactly the same result. Alright, that's it for keyword arguments in Python. It's a good practice to add description to each function that you define in the Python application. And that is done in the following way. Let's define function called sum with 2 parameters, a and b, and here with function body. Description is added at the beginning of the function body using triple quotes, either double quotes or single quotes. So let's add them like that. And here in between, add description of this function. Sums to numbers, like that. And let's return a plus b. And now if I call this function like that, I'll see such description here in IntelliSense window, sums two numbers. And now I'm able to call this function with two arguments, let's say 2 and 5. And as a result, I'll get 7, and if you want, you could print this result to the terminal, like that, run application, and I'll get 7 in the output. That's description of the function. Also, if you want, you could split it to multiple lines, like that. Sums two numbers, numbers must be integers, like that. Run application, I see same result, and now if I hover mouse over sum, I'll get such description as sums two numbers, numbers must be integers. That is multi-line function description. Alright, that's it for functions in Python. Now let's have a look at the comparison operators in Python. They are equal, not equal, greater, less, greater than or equal, less than or equal. And expressions with all those operators are evaluated either to boolean true or false. Let's define two variables, a is integer 10 and b is integer 12, and let's print to the terminal a equals sign b. Let's say run, and I get false, because this expression now is evaluated to boolean false, because a is not equal to b. If I modify b to 10, I'll get boolean true. But what if b is string 10? Like that. Let's see what we'll get here. I'll get false, because now those variables have different types. Here is integer and here is string. And in such case, such expression with comparison operator is evaluated to false. Alright, let's get back to number 5, for instance, here, and let me duplicate this line several times, like that. Here will be non-equal, here will be greater than, here will be less than, here is greater than or equal, and here is less than or equal. Let's run the code and I'll get following results, and they are pretty self-explanatory. That's basic math actually. If those values will be equal, let me modify value of the variable a to 5 and run the code, I'll get true here on this line, a is equal to b, and I'll get true on those lines, a greater than or equal to b and a less than or equal to b produce true in this example. That's our comparison operators, and again, expressions with such operators are always evaluated either to boolean true or boolean false. Let's now have a look at the logical operators in Python, and they are AND, OR, and NOT. Expressions with logical operators AND or OR are evaluated to specific value. NOT is always evaluated to either boolean true or false. Let's have a look first at AND operator. Let's define two variables. A is, let's say, string abc, and b is number 5. And here let's print to the terminal result of such expression as a and b. Let's see what we'll get, and I get 5. And that's actually value of the second expression here, second operand of the AND operator. If I modify a to empty string like that, I'll get empty string here as a result of this expression. Why? Because now AND operator will return first falsy value, and a is now falsy, it is empty string. Or for instance, if a is 0, it is also falsy value. We discussed falsy values before in this crash course. If I run code now, I'll get 0. But usually such operators as AND, OR, and NOT are utilized in conditional statements, and we will talk about them a bit later. And the result of such expression will be truthy in case both operands, this one and this one, are truthy. But if at least one of operands, this one or this one, is falsy, then result of such expression will be falsy. For clarity, let's print here to the terminal result of conversion to boolean value of expression a and b, like that. Let's run code now, and now I get false, because one of those values is falsy, this one. If I modify a to number 10 and run code, I'll get true, because now this expression is truthy. Both values are truthy. If B will be falsy, let's say none, result will be false here, because none is falsy value. If A will be none, and B will be, let's say, number 5, result will be the same, because it doesn't matter which of operands is falsy, either this one or this one. In both cases, we'll get here on this line false. Also, if I add here one more variable, for instance c, and its value will be string a, and here I'll add it to this expression, and c, and let's add it here as well, and c, and run code, I'll get exactly the same result as before. Here on this line I'll get none, it is value of the a, first operand here in this expression, and on this line I'll get false. And it means that actually it doesn't matter which values b and c have here in this expression, because Python sees that value of the a is falsy. That's why there is no need to evaluate all next expressions, here and here, because here are actually expressions. And Python stops here, in this example, after evaluation of this expression, because this expression is falsy. But if a is truthy, for instance string abc, it continues evaluation to other operands. And now I get a, it is value of the variable c, last one. Because a was evaluated, it is truthy, that's why we proceed to next expression. Value of the b is truthy as well, that's why we proceed. And finally we evaluate this expression. It is truthy as well, and that's why it is returned as a result of this expression with two AND operators. And result in total is truthy when it is converted to boolean. But if b is falsy, for instance 0, then c will not be evaluated, and Python will stop here after evaluation of the expression b. And that is called short-circuit evaluation. It does not matter what comes next if we already found first falsy value in such expression. It is immediately returned as a result of the expression, and the remaining part is not evaluated. For instance, I could type here and print not called, like that. Let's run this code, and I don't see not called here in the terminal, because this expression was not evaluated. This function call is actually expression. But if I change value of the variable b to truthy value, for example number 2, and execute code, I'll see not called here in the output, because now this expression was evaluated. Print function actually returns none, that's why here on this line we get none as a result of this entire expression. But on this line we still get true, because here I didn't change c to print, and c is still truthy. That's why this expression is truthy. That is called short-circuit evaluation in Python. Alright, let's proceed, and next let's have a look at OR operator. Let's remove this second AND from here like that, and let's remove AND from here as well. And let's replace AND here and here with OR, and let's get rid of C variable like that. Let's now save changes and run code, and now I'll get ABC as a result of this expression A or B, and this expression is truthy, that's why here I'll get true. And as you see, this expression was evaluated to first truthy value. It is value of this expression here. If I make value of the a falsy, empty string for instance, I'll get 2, it is value of b, but still this expression is truthy, a or b. It will be falsy only in single case, if both operands here and here are falsy. For instance, a is empty string and b is none. Let's see what we'll get now. I'll get none as a result of this expression. It is the value of last operand b here. And of course, such value is falsy. That's why here I'll get false. And that proves that such expression will be evaluated to false only in case both operands are falsy. You could of course chain OR and add one more OR here, for instance OR C, and here also OR C, and let's add C here, and let's make it number, for instance 10. Let's run code, And now I get truthy value because one of operands is truthy, it is C, and its value is returned as a result of this expression. Rule is same as before. First truthy value is returned back as a result of such expression. But if C will be falsy as well, for instance number 0, I'll get 0 as a result of this expression A or B or C, and of course such value is falsy. That's why here I'll get false as a result of conversion of this expression to boolean. But as soon as Python finds first truthy value, for instance string here ABC, let's run the code, it will be returned as a result of such expression. And Python stops and doesn't evaluate all remaining expressions, this one and this one. OR operator is also short circuit. Now let's have a look at the NOT operator that is evaluated either to true or false. Let's define only single variable and let's make it string A, like that, and let's print the terminal not A. Let's see what we'll get. I'll get false, because A is now truthy value and not A is false. But if A will be empty string, I'll get of course true, because now A is falsy value and not false is true. It's possible to use NOT operator twice like that, not A, and in this example I'll get false, because A has now falsy value. But in a nutshell it is equal to such expression, print bool A. In both cases I'll get false. And if you want to check whether specific value is falsy or not, better to use such conversion to boolean instead of not A. Of course, you could chain different logical and comparison operators, for instance such expression as 5 and string ABC and not number 3 is fully valid Python expression. Let's see result, and result is false. But please be careful when you combine AND and OR operators. For instance, if here will be OR operator like that, I'll get 5. But if I put this part of this expression into parentheses, like that, here opening paren and here is closing paren, I'll get different result, I'll get false. Because now with those parentheses in place, this expression must be truthy, and this must be truthy. But if I remove parentheses and get to previous variant like that, this value will be returned back as a result of this expression, because Python processes operands one by one. And here we find first truthy value before OR operator, and that's why it is returned back as a result of this expression. That's why if you want to mix OR and AND operators, please use parentheses in order to modify order how Python interprets such expressions. Alright, that's it for logical operators in Python. Conditional and logical operators are most often utilized in if conditional statements. And now let's talk about them. Syntax consists of such keywords as if, elif, and else. Let's start just with if keyword. Let's define new variable and let's call it name, and let's assign value to it, for instance Bogdan. And here will be condition, if name, let's perform some action, let's print name to the terminal, like that. Let's save changes, run code, and I see Bogdan here in this output, because now this condition is truthy. This means that in if conditional statement, this block of code is executed only if such condition is truthy. You could add here multiple statements same as you do in function. For instance, you could print name twice, like that. It is fully valid block of code inside of the if statement. But if this condition is falsy, for instance, if name is empty string like that, then this block of code will not be executed. And if you want to execute other block of code in case this condition is falsy, then you could use else statement like that. And here let's print to the terminal string name is empty, like that. Let's run the code and I get name is empty in the output. Also, it's possible to add elif part to this if conditional statement. Let's get back to name Bogdan and also let's add surname I'll put my surname here, like that. And now let's do following. If name, let's print name. Next, after this if statement, let's add else if statement, shortly elif. Here will be one more condition, elif surname. Let's print surname. And here in this else block, instead of name is empty, let's write name and surname are empty, like that. Let's run the code, and now I get Bogdan, because Bogdan is not empty. If it will be empty, or for example none, I should get my surname, and yes, here it is. If surname is also falsy, for instance empty string, I'll get name and surname are empty. But what if I want to add one more condition and print both my name and surname in case both of them are present? Let's get back to real values here, and let's think where we should add this new condition. For instance, let's try to add it here. elif name and surname. Let's print name and surname, like that. Let's now save changes and run the code, and I'll get Bogdan. Because if conditional statement stops here when this condition is evaluated to truthy. It does not proceed to other elif statements here, here, or to else here. That's why more specific condition, for instance this one in our example, we need to put above, before those less specific conditions, this one and this one. Let me cut it from here, like that, and put it here, at the beginning of this conditional statement, and of course modify elif to if here, and if to elif here, like that. Let's now save changes, run code, and now I get name and surname. And if name is falsy now, like that, I'll get only my surname here in this block. That's how conditional statements work in Python. Only one block will be executed, either this one, or this one, or this one, or this one, if all previous conditions were falsy, like for example now. And basically under the hood, Python converts each expression to Boolean. It means that such condition and condition bool name and surname is equal to true are the same. But you don't need to perform such conversion yourself. Python does it for you under the hood. That's why you only need to enter specific expression in the condition part and don't care about its conversion to Boolean. Alright, that's it for if-else statements in Python. Now let's talk about strings formatting in Python. Strings formatting is required when you, for instance, want to create a string and insert to it values of some variables. Let's say that there is variable name and its value is Bogdan, and also there is variable, let's say, drink, and its value is tea. And I want to create new string Bogdan likes to drink tea. And I could do that in following way. Print name plus operator string space likes to drink, one more space, plus operator drink, like that. Let's run this code, and I get string Bogdan likes to drink tea. But this approach is not convenient for use. That's why there is a feature called strings interpolation, and you could, instead of this expression, write following. F, next will be double quotes or single quotes, and here will be name in curly braces. Next, just continue to write string likes to drink, like that, and here will be one more expression in curly braces, drink. Let's now run the code, and I get exactly the same result. This is called strings interpolation, and Python interprets such expression at the runtime when it is able to evaluate values of those expressions, because here you could put any expression you like. For example, name.upper, like that. Run, and I get Bogdan in uppercase. Between those curly braces, you could put any valid expression, even function call if you want to do so. This feature is available in Python starting from the version 3.6. There are also other possible ways to format strings, but that's my favorite one, and that's the most simple one. And that's why I will not explain to you older and honestly more complicated approaches to strings formatting. That's how you could very easily format strings in Python. Let's now have a look at errors in Python code. And for instance, let's write 10 and divide it by 0. Let's run such code, and I see in output 0 division error, division by 0. And if you attempt to perform some other actions after this line of code, for instance, let's print to the terminal continue, like that. Let's rerun code. I will not see continue here in the output, because actually program crashed. On this line, we performed division by 0 and there was an error, and here is traceback of such error. That's why, if you want to proceed, in this example, to this statement and call print function, then you need to wrap this line of code into try except block, using following syntax. Try, and here select from the drop-down menu this option. If you press it, you'll see that VS Code will autocomplete for you try except block. And here let's move this line to try block, like that. Let's divide 10 by 0. And here in except section, let's simply keep pass. Recap that pass is special statement that does nothing, and is very useful in places where Python actually expects block of code. Let's run this code now, and I get continue here in the output. This means that this error that occurred here on this line was handled in this block. And basically you are able to process in some way specific error that occurred here in this try block. Let's recap which type of error we got here. Let's move it outside of the try except block, run code, and error was 0 division error. And we could take this type of error from here and put it in except block, except 0 division error as e. E here will be variable. Let's print to the terminal e, like that. And let's of course get rid of this line here. Let's run the code, and I get string division by 0. It is value of the e variable here inside of the except block. And that's what actually comes from 0 division error type. And code continues its execution. That's why here on this line I see continue string in this output. That's how you're able to handle different types of exceptions using try except block in Python. Last topic in this Python crash course is Python modules. And using Python modules, you could split your Python application into different files and define different parts of your code in different files as well. And essentially, every file in your project that has extension .py is Python module. And now there is only single module called main.py. There are also system modules that you could use in your modules. For example, there is module called math. Also, there are external modules that you could install if you need to use them. Let's start by using built-in modules in Python. And if you want to import some variables from another module, you need to use import keyword. You could import only specific variables from other module, or you could import entire module. For instance, let's import module called math. It is built-in Python module. And here you could read that this module provides access to the mathematical functions defined by the C standard. Let's perform import of entire module. And now here in main.py file we are able to access any variables defined in this math module. And if you type math and add dot, after dot you'll see all possible variables that are present in the math module. And you are able to use any of those variables inside of the main.py file in your own module. For example, you have access to the variable called pi. It is basically pi constant. And if you print, you'll actually see float number. Here it is. In similar way, you are able to access any variables defined here in the math module. Let's now create our own module. Let's remove that from here. And let's create in our project new file, and let's call it own_math_module. Name could be any you want, with extension .py. Here in this own math module.py file, let's define function called sum, with two parameters a and b. Here let's add description for this function. For instance, sums two numbers. And let's return a plus b. Very simple. That's what you need to do here in this file. And now we are able to import this sum function from the own math module into the main.py module very easily using same keyword import own math module. Notice that VS Code suggests me name of this module because now it knows about presence of such module in our Python application. That's why let's press tab in order to autocomplete name of this module. And now here I could access any variables defined in this module. Let's call some function defined here in this module. Simply like that. Own math module dot sum. Here again you see suggestion. And let's call it with two arguments. Also here you see name of two parameters a and b. And description of the function sums two numbers 5 and 6. And also let's print this to the terminal like that. Let's run the code, and I see 11. That's how very easily using import keyword you are able to reuse functionality defined in other Python modules. If you want, you could also import only specific variables using following syntax. From own math module import sum. And now on this line we don't need to access own math module dot sum, simply call sum like that. Let's run the code and result is the same. This means that if you want to perform selective import only from some variables from the module, you could use such syntax. From name of the module, import, and here names of the variables you want to import. If you want to import entire module, you could use simply import keyword. That's it for Python modules. And that's actually it for this Python crash course. As you've seen, Python is a relatively simple language, and it is very close to the human language. There are such words as and, or, not, and not so many special characters. Now you know basics of the Python language, and I wish you good luck in further exploration of the Python.